I'm confused on how you get the 2 times. Like when you're like doing like in any of them, not even in just this one, but how you get that how you get the fraction to do it.
The ratio 2 to 8 would be 2 to 2 tenths. We'll stop at that a little bit. Okay. You might have missed that day. All right. Any questions 1 through 6? All right. I'm guessing you're going to want to see 7. All right. 7. As I go around, I want to make sure you guys are labeling point A and point B here, because part of the problem is if A is on the other side of B, you do have to go from A to B, and that way, in that situation, you're not going left to right, you're going right to left. And so you have to have A and B labeled just so you can be careful to get these horizontal changes correct, +8 or -8, +14 or -14, right? So be careful with that. Now, a ratio of 2 to 8, remember we talked about pie, or pizza or pie or whatever it was one day. If you get a ratio with another person of 2 to 8, you get 2 tenths, they get 8 tenths, right? So the ratio we're using here is 2 tenths. And so I found the horizontal change. It's +8 from A to B. I found 2 tenths of 8, which is 1.6. 1.6 is not my x value. I have to start at A and move right 1.6. And then I do my vertical. 2 tenths of 14 is 2.8. That's not my y value. That's how far up I'm going from A towards B. And so that's kind of like directions. It's a directed line type. You're giving person directions. Start at A, go right 1.6, go up 2.8. Well, since A's x value was 0, when you move right 1.6, you're at 1.6. But since A's y value was -5, when you move up 2.8, you're at -2.2. Are we starting to feel better with these kind of problems? Okay. Any specific questions I can help you with on this? I know it's multiple steps, but I think we're getting better. And then when you go to graph it, make sure it looks correct. You're 2 tenths of the way. 2 tenths is 1/5. Does it look about 1/5 of the way? Yeah. Eight. Write the equation of the line parallel to y equals 3x, 3/4 x plus 6 through the point -8, 3. Parallel tells you they have the same slope, 3/4. They're going to have different y-intercepts though, so you have to find the b value to plug in to make it go through the point -8, 3. So you plug in 3 for y, -8 for x. You solve for b, and I got y equals 3/4 x plus 9. Y equals 3/4 x plus 9. When you write the equation of a line, it should have an x and a y. It should be in slope-intercept form for these. Slope-intercept form. Does that make sense? All right, we ran out of room for number 9 on here, so we're going to do it on another page. Come on. All right, write the equation of the line perpendicular. So we're thinking opposite reciprocal slopes. But as you look at this, you should not say, oh, this slope's 9. This is not in slope-intercept form. I have to subtract 9x, divide by -3, and I get y equals 3x minus 4. That's this line right here. I really haven't done any work to get the new line yet, but I can look at this problem, at this equation, and say the slope of this line is 3/1. So my perpendicular line is going to have a slope of -1/3. Do we know it's y-intercept? Do we know, excuse me, do we know the new lines y-intercept? No. So we write y equals negative 1/3 x plus b. I don't know what b is yet, but I have a point. I know this new line goes through the point negative 2, 4.
Good morning. Please excuse the interruption. The internet is temporarily down. Don't panic, but please, we don't need to keep calling to say that there's a problem. We are aware and we are working on it, and we'll let you know as soon as it is back up and running. So for now, enjoy some downtime without the internet, and we'll let you know when it gets back up. Thank you.
3 1/3, 3.3 repeating, 10/3, however you would have wrote that. That's fine. So now we have the y-intercept. We have b. So now we write our specific equation, y equals negative 1/3 x plus 3 1/3. Make sense? That is the line perpendicular to the original, and it goes through the point negative 2, 4. Okay? We made it go through the point negative 2, 4. We plugged in negative 2 and 4 in for x and y, and we found the y-intercept that it went with. Okay? All right, back to this one. Number 10, find the distance from A to BC. A, BC, everyone should know that's the shortest segment. So I used the distance formula. I got radical 45, which is either 3 radical 5 or 6.71. 3 radical 5 or 6.71 for that one. Over here, number 11. Got a lot of questions on this one. Do not overcomplicate this. Okay? If you're asked to tell which lines are parallel and perpendicular, I have good news for you. You don't have to write the equations of the lines. All you have to do is look at their slopes. Same slope, parallel. Opposite reciprocal slopes, perpendicular. So I saw a red line, blue line, green line, and purple line, and I found their slopes. And as I was checking some people's work, I didn't see any labeling. All I saw were a bunch of calculations written all over. Okay? I'll be honest, that would have been me in high school as well. As I've kind of learned, hey, I'm going to make a lot of mistakes if I'm not organized. I highly recommend you label these: the slope of A, the slope of B, the slope of C. And if you stay organized, then you won't have to go back and guess which one was which. You have it written down. And so the slope of A was negative 3/1. Slope of B was negative 3/1. Those look the same. They're parallel. The slope of C was positive 1/3. Is positive 1/3 the opposite reciprocal of negative 3? Is positive 1/3 the opposite reciprocal of negative 3? So yeah, C is perpendicular to B, and C is perpendicular to A, isn't it? And D was the weirdo, 5/8. Poor guy. All right, so I had A as parallel to B, I had A as perpendicular to C, and I had B as perpendicular to C. If you wrote it out in words instead of symbols, that's fine too. Page.
Did you have to write both, like A is perpendicular to C and B is perpendicular to C? Or
Yes.
Did you just write one?
It said, let's read the directions just to make sure I answer correctly. Determine which lines are parallel, which ones are perpendicular. So if you just wrote one of them, like A is perpendicular to C, that's true, but B is also perpendicular. So you're missing that. You might be missing one of the two. All you have to do is look at slopes. Now, Mr. Westfall, if it's one on the graph that I can just count, rise and run, can I just do that instead of showing the calculations? Yeah, that's fine. All right, that's fine. But if I don't give you a graph and I just give you points, you do need to be able to calculate it using the slope formula and then compare them. All right. Did I skip one? 9, 10, 11, good. 12. 12 is the tough one. Can you guys see this? Can you see it right? Look how close they are, right? Really close. Man, if these little blocks are 1 unit by 1 unit, that distance from the red point to that line is not very long. Callie?
Is this what the test is gonna look like?
Yes, it is. Maybe shorter.
Will you give us a graph on the test for like this questions, or will we have to draw our own?
It's a good question. By the way, the answer there is 0.89 is what I got. Yeah, it looks like if I give you one like this, or the directed line segment, that was the 2/10 problem. I gave you a graph. All right, step 1. Write the perpendicular line. Write the equation of the perpendicular line. Well, this one has a slope of -1/2. The perpendicular line is going to have a slope of +2/1. Okay? It goes through the 0.62. So again, that's the process of finding the y-intercept b. So I plugged in 6 for x and 2 for y, and I solved for b. I got b is -10. So now I'm able to write my equation of the perpendicular line, 2x minus 10. That line would look like this. If it went on forever, that line would look like this. Does that line make sense that it has a y-intercept of -10? Mine's not drawn to scale, but do you see how it is going to cross the y-axis down here, right? It's reasonable. So that's that line. That's not what I want. I want the distance between this line and the 0.62. So there's the 0.62. I use that line that I just found. Well, you guys tell me. We've been going over this a few days now. Okay. Why did I find 2x minus 10? Why did I have to find that line?
It's the slope.
Why did I have to find the equation of this line right there? Okay.
Because you have to set it equal to the other one to find x and then to find y.
To find that point where they
Intersect.
very good. Because if I need to find a distance between these two lines, or a point and a line, I need to know the point where they cross. So I can find the distance between the point they gave me and the point where they cross. Very good. So now I use the two lines. I set them equal, and I solve for x, plug it in to get y. That is my point, 5.6, 1.2, where they intersect. So now I've narrowed it down. I had this whole line, but now I'm only looking at just a small little portion of it between the 0.62 and the intersection point 5.6, 1.2. I use the distance formula and I get the length of 0.89. 0.89 is less than 1 unit, which seems reasonable because that little segment is pretty short. The points are pretty close to each other. Makes sense. All right, next. Given L is parallel to M, S is parallel to T. Ooh, I like when they give us parallel lines. That means all of the corresponding alternate interior, those are all fair game. Now, I want to show, I kind of plan out my path. I look at what they gave me, then I look at where I'm heading. I want to prove that 1 and 6 are supplementary. All right. So I'm kind of thinking through, I'm thinking, okay, 1's congruent to 4 corresponding. 4 is congruent to 3 vertical angles. If 1's congruent to 4 and 4 is congruent to 3, then 1's congruent to 3 transitive property. Correct? With me so far. 3 and 6 are consecutive interior. That's my reason, but my statement is that they are what consecutive interior angles are. Well, the lines are parallel. Consecutive interior angles are supplementary, which means they add up to 180. Right? You with me? 3 plus 6 equals 180. Oh, wait, I just showed 1's congruent to 4, 4's congruent to 3, so 1's congruent to 3. So instead of 3 plus 6 equals 180, I can plug in 1 plus 6 equals 180, and then therefore they are supplementary. Okay, so that's our path. I know it's a lot, so we have to take it kind of piece by piece. There's other ways you could have done this. You could have said 1's congruent to 4, corresponding. 4 is congruent to 5, corresponding. And then, oh, look, you could use the linear pair theorem, and then you could use alternate interior. Get it that way. Okay, that's fine too. Actually, no, you would have just done 1's congruent to 4, 4's congruent to 5, so 1's congruent to 5. And then substitute 1 in for 5. And then 1 and 6 are supplementary by the linear pair theorem. Something like that. That'd be fine too. There's different ways to get there. All right? All right, I'm going to go the first path since I used that one already. Angle 1 congruent to angle 4. Corresponding angles. Okay? Angle 4 congruent to angle 3. Vertical angles. Angle 1 congruent to angle 3. Transitive. Not transversal, transitive property. Some people are still putting transversal property there. Okay. Also, some people are putting substitution there, and I let it slide on the quiz. I corrected you a couple times now. Transitive property is used for congruence. Substitution is not used for congruence. Okay. So if you're going to say 1's congruent to 4, 4's congruent to 3, so 1's congruent to 3, that is the transitive property. All right. All right. So 1's congruent to 3. Well, angle 3 and angle 6. Well, did you guys go straight to measure of angle 1 plus measure of angle 3 plus measure of angle 6 equals 180? There's a couple ways to do this. I will clear up any questions you have once I write this down. Come on. Consecutive interior angles. All right. Ella.
After we say that angle 1 is congruent to angle 3, do we have to say that the measure of angle 1 equals the measure of angle 3?
I was just going to say that. You read my mind, Ella. Yep. So either I put it right after that step, or I say, oh, look, I need to convert to measures. And so you either put it after the step or you can put it under the step. And here's what I was going to say. I wrote this as my next step. And then now I realize, from a student standpoint, oh, I'd really like for them to say 1 plus 6 equals 180. If I want to substitute a 1 in there, I need to have said measure of angle 1 equals the measure of angle 3 so I can substitute. And so either here or here is fine. What Ella's saying is measure of angle 1 equals measure of angle 3. Definition of congruent angles. And again, why do we have to put measures? Because it's not the physical angle, it's the measure of the angle, and that's allowed to be substituted into an equation. So we want to have measure of angle 1 plus measure of angle 6 equals 180 by substitution. And if 1 plus 6 equals 180, that means angle 1 and angle 6 are supplementary. That's the definition of supplementary angles. We went from saying that their measures add up to 180 to saying in words they are supplementary. That's the definition of supplementary angles. Two angles whose measures add up to equal 180. Does that make sense? Again, there's other ways to get there. If you use the linear pair theorem, it's probably okay. If we have time, I can check it for you. All right, we're proving the alternate exterior angles theorem. What's the only one we can't use? Alternate exterior. We're told the lines are parallel. I've said the lines are parallel. 2 is congruent to 4 no matter what. Angle 2 is congruent to angle 4 because of... You guys got it. Angle 4 is congruent to 7 corresponding. If 2 is congruent to 4 and 4 is congruent to 7, then 2 is congruent to 7. Alternate exterior angles, right? No. Transitive property. If you put alternate exterior angles there, you're missing the point. Okay? Be careful. I'm not trying to be rude, but just you have to check your understanding of what a proof is. We're trying to prove that theorem. We had to get there another way. Okay? You're going from North Canton, the road's closed, you have to get there another way. Detour. Can't use that road. All right. Next one. L parallel to M. I'm going to mark it on the picture. It's already marked. I like to mark it again. Angle 1 congruent to angle 3. Name angles 2 and 3. Corresponding. Are those corresponding angles congruent? Only if the lines are parallel. Are the lines forming them parallel? Yes. Name 2 and 3. Alternate exterior. Are those alternate exterior angles congruent? Only if the lines are parallel. Are we told P and R are parallel? No. So you cannot say 2 is congruent to 3 alternate exterior angles. That would be wrong. Okay? You cannot say that. But we can say angle 1 is congruent to angle 2. Reason? Corresponding. Let's see if this is going to help us. If 1's congruent to 3 and 1's congruent to 2, then
2's congruent to 3.
2 is congruent to 3. Alternate exterior, right? No, those lines aren't parallel. Transitive property. You guys are doing awesome. Okay. Oh, look. This pair of, they're still called alternate exterior. They're still called that. We just couldn't say they were congruent because of it. Oh, look. Those alternate exterior angles are congruent. That means the lines are parallel. What theorem did I just recite? Careful. What was the first word? Converse. Alternate exterior angles there. Yes, I will count off if you don't put converse. That's the whole point. You're proving the lines are parallel. I need to pause here real quick. I'll get your question in just a second, Ella. There was a time in the not too distant past where you guys were really worked up about proofs. And I said, just see more and more. You have to see a bunch of them and go through and struggle and ask questions, and it will get better. Come on, do you guys feel like it's getting better? These ones. You probably could do these on your own, right? If not, we need to talk. But if you have been doing your homework and worksheets consistently and trying to keep up with everything and going back through things and studying and correcting and all those things, it should be getting better. These should be pretty straightforward for you. All right? And if it's not, I'm not trying to make you feel bad. I'm just trying to let you know where we kind of stand right now. And what I'm hearing is a lot of you guys are confident with these now. That's awesome. I'm glad to hear that. Ella, question or comment?
I keep mixing up, like if I were to say that it is the converse of alternate exterior or interior, I keep mixing them up and saying like interior, because I'm not sure how to tell if they're interior or exterior.
Thank you. All right. What lines are we talking about when we're talking about 2 and 3? What lines connect them? M is the transversal. And then what are the 2 lines? Isn't angle 2 formed by M and P? Isn't angle 3 formed by R and M? And so we have the transversal, then we have these 2 lines. The interior is here. It's between the 2 green lines. The exterior is out here. So the name alternate exterior means they, 2 and 3, alternate sides of the transversal, left and right. Exterior means they're both on the outside of those 2, what we now know are parallel lines.
Okay.
If they were here and here, they would be alternate interior. They'd be between them. Is that what you're asking? How do I know the difference between alternate exterior? Does that help at all?
Kind of, but like, isn't 2 still exterior?
If 2 was here and 3 was here, they'd be alternate and interior between.
Okay.
3 and 4 are alternating sides of the transversal and are outside those parallel lines.
Okay.
Exterior. Thank you. Questions? Kelly.
So these are the kind of proofs that will be on the test.
Similar. Yep. I'm not promising they're the same ones, but similar. Last one. All right. 1's congruent to angle 4. And angle 3 and angle 4 are supplementary. You could have put those on different lines if you wanted. All right, mark them. Angle 1 is congruent to angle 4. Ooh, what kind of angles are 1 and 4? Now, Ella, here's your transversal. Here are the 2 lines that we're talking about. Are 1 and 4 on the interior of the green lines or on the exterior of the green lines? Interior. So they're alternate interior. Okay? If it were here and here, it'd be consecutive interior. All right. Should we go ahead and say that L is parallel to N? Is that the next step you guys did? Or did you say the measure of angle 3 plus measure of angle 4 equals 180? Or neither? What was your next step? Olivia?
I did 2 and 3 are like
Congruent?
because of vertical angles, and then 1 and 2 are supplementary because of substitution.
Well, we don't have any equation yet, so we can't use substitution. Let's do this. Tally, go ahead.
I said 2 is congruent to 3 because the vertical angles theorem, and then I said M is parallel to N because of the converse of consecutive interior angles theorem.
Okay. Okay, so we have 2 things we can say right now. I like that, Tally. So you said if 3 and 4 are supplementary, that means M is parallel to N. M is parallel to N by the converse of the consecutive interior angles theorem. If consecutive interior angles are supplementary, then the lines forming them are parallel. Well, we're told 3 and 4 are supplementary, then that means M and N are parallel. Boom. Agree? Well, 1 and 4. 1 and 4 are congruent. Oh, look. Those alternate interior angles are congruent. That means the lines forming those are parallel. L's parallel to N. Converse of corresponding angles. Wait, did I say 1 and 4? No, sorry. Converse of alternate interior. I didn't use corresponding. Alternate interior. Everybody see it? This is one we haven't used much. Preston?
Did you do the, it's like something to do with the transitive property?
Yeah. And that's new to this book that we hadn't used in the past. Do you remember what it's called? We only talked about it once. There is a transitive property of parallel lines. Remember that? If L's parallel to N and N's parallel to M, then yeah, if L's parallel to N and N's parallel to M, then L's parallel to M, the parallel lines transitive property. Now, there's other ways to get there. Some of you were fine. Olivia, you said vertical angles. Callie said vertical angles. There's other ways to get there. Ready? They said 2 is congruent to 3, right? We knew 3 and 4 are supplementary. And so, I mean, there's just, you could say 3 plus 4 equals 180. We can't say 1 plus 2 equals 180 anywhere in here. Why not? Why can't I, at any point here, say 1 plus 2 equals 180 because they're consecutive interior angles? Christian?
It doesn't say that.
We don't know that L and M are parallel. Perfect, right? But what if you got there? What if you got there through a substitution? Then you could say the lines are parallel, right? So if you somehow showed 1 plus 2 equals 180, not because of consecutive interior, but because of a 3 plus 4 equals 180, and a 4 is congruent to 1, and a 3 is congruent to 2, and you did multiple substitutions. Oh, look, 1 plus 2 equals 180. The lines are parallel. Converse of consecutive interior angles. Tom?
Could I say, after saying M is parallel to N, could I say angle 1 is congruent to angle 2 because of the linear pair theorem, and then say
1 and 2 are not a linear pair. They have to be adjacent to be a linear pair.
Yeah, I don't know what I did wrong there. Never
Okay.
mind.
If I have time, I can check it. All right, you have a test tomorrow. This test review, I've looked. I've made the test. Made the test review. Okay? I'm not saying the exact proofs are going to appear on the test, but ones that are very similar. I'm not throwing, for a test, a chapter test, I'm not throwing in some random proof that you've never even seen a type of it before. I'm not saying it, I'm saying a type of it. On a quiz, that's fair game. You should be tested to see what you can do on a quiz. All right, a test is more straightforward of things, the typical problems we've done in class. Okay? Have you done the extra practice problems in the book that were on last night's agenda? They were optional. I'm not holding it to you. Holding you guys to it. But if you are struggling and you want to do well, or you just want to make sure you got it, you can practice those problems, all right, that are on the agenda from last night. And if you don't do well in the test, and I talk to parents or I talk to you and I say, what did you do to prepare? I said, did you do the extra problems? And you say, no. And I say, maybe you didn't do everything you could have, all right? So be responsible, know what you need to do. And I hope everyone gets A's tomorrow. Okay. Let me stop the recording real quick.
I did. I was trying to put myself forward.